So let us start our class this morning. There are some updates on our slides. So if you downloaded our slides a while ago, so please get the latest version. So we are discussing module 4, right? Repetition structures. And from next week, we'll discuss functions. That is another important thing. Okay, so actually module 3, 4, and 5. These are the main foundation of a programming language. If you understand this, then hopefully you will be able to start programming, be able to start solving a problem. Like in this chapter, we discuss already while loop, do while, and for loop. Okay, so these are the interesting steps. If you understand, then and if you do practice, the more time you spend for practicing this program, you will learn more. And sometimes I know that you will do some mistake. If you do some mistake, don't be hopeless. Try to learn something from your mistakes. And this is the way that we people learn how to do programming. There is no shortcut way. I learn or other people learn. Everybody practices. So one of the problem we wanted to discuss in our lecture this one. Display a number in reverse order. Okay. Anyone wants to volunteer? We want to explain what happens when we do this, when we do this, when you do this, these 3 lines. Anyone wants to volunteer and wants to explain? How many of you did practice? Who practiced this program at home? You? Are you coming? Yeah. Yeah, I don't explain these freelance.
Okay, so basically, if they're asking us to write a program where you can take in a user input and then output the reverse order of that. So I'm not going to do like using systems or anything like that.
Just take a number, fixed number.
Just the concept.
Yeah, take a number.
All right. So first thing you have to do is.
For instance, take a number. For instance, a number equal to 1, 2, 3. You can.
You just want me to do an example then?
Yeah.
Oh, okay.
Explain with an example. Yes.
I have a program where it says enter a positive integer, it's going to prompt you to enter in a number. And so we'll say 327. the output, it will say the reverses. It will output 720. And then let me just do the code for you.
Yeah.
Explain how it works.
Yes.
All right. So basically, the first thing is you have to declare the variable, or you have to declare the variable. So you're going to have the input as number. You also have to have variables for, and I'm writing this in C#, the last digit, and finally the reverse, which is what's going to be the output. So you're going to want to print positive integer. Then you're going to want to read that into the number section. But you have to apply the convert to 32. So read it as an integer. And once you've got this number stored, you have to use a do while. So we have last digit. We want to figure out how to find the last digit of a number. So if you have any number that's like 2 digits, 3 digits, however many digits, the way you find this alone is you mod it by 10, which eliminates these 3 digits that leaves the last digit alone. So last digit will equal the number modded by 10. And now we can write that reverse is going to be last digit. This is all while the ending part of it, what was supposed to be within the while break. All right. Greater than equal. You have to put a semicolon at the end because this is not part of the do this as a separate statement. So when it comes to that right line, you want to print the reverse. Not sure also if this is supposed to be number or this is also supposed to be reversed. I know everything else is correct.
Which one?
So for the
yeah,
I'm not sure if this is supposed to be not. Also supposed to be reversed, like reverse.
It should be reversed.
Okay. Then you can do reverse plus equal. So basically the way it works is you have the number 27 into this function, 27 10 is going to leave you 7. Then it comes back around, so you have 7 is stored in reverse, and then what you have left is going to be divided by 10. Yeah. All right. Where did that take place? Supposed to go in between these two. All right. So this gives us last digit. And times 10 plus last digit. And the number divided by 10. Number equals number divided by 10. And basically what you're doing is you're getting each last digit. We're adding in the next one, like 70 plus 2, 72, and then 720 plus 3, when you make it 3, I get 723. So it keeps looping and doing that, adding a 0, and then adding the new last digit to the end, and then just getting the final answer, right?
Okay. Thank you so much. Thank you, Nicholas. Yeah, actually, we have a trick over here. So let me explain a little bit. So Nicholas, he explained, initially we enter a number 327. For instance, 327 over here. My number is. Okay. So we know that if we reverse this number, there is no way. Okay. So this is a number for string operations. Later we will discuss about string operations. For string operations, there is a built-in method. It's called string reverse. In some programming languages, there are some built-in methods for like string reverse. That if it is a string, okay, then easily we can put this value as an argument string reverse method, and then the string reverse method will display the digits reverse. But there are problems of using that method because that is a built-in method. We are encouraged to develop our own method, own algorithm. We do not know how the string reverse method works. And string operation works only for a string. So So the number, so my number, for instance, n or number, this is a number. The difference between a number and a string is huge. When you code this within double quotation, that will be number. So that will be a string. But this is a number. We can do arithmetic operations, but we cannot do arithmetic operations on a string, right? So the string reverse method should not be applicable here. Okay. So for instance, this is my number. So what do we need? We need to display the number last more digit 7 first. Okay. And so how do we get the right digit? So if we take the modulo of 10 number, then we get the rightmost digit 7. Okay. Then we need to put a digit somewhere. For instance, initially a reverse variable, that is 0. So then reverse initially, that is 0. Then reverse will be reverse 10, 0 in the first phase, 0 times 10 plus last digit. My last digit is 7. Okay. And if I have only one digit, then it is done. It says while number is greater than 0. If I would have one digit, then this is the termination point. Then I would print a reverse number. But I have more digits, 2 more digits. So how can we get 32? Extract 32 from 127. The way that if we do integer division with by 10, we will get 32. So our initial number was 327. So now we will get 32. Okay, so my number now 32 is greater than 0. So then we will go to the do loop again, and then we will find the second, and we will find last digit. This time it will be 2 last digit. Remember that our previous reverse was 7. So this time my reverse will be 7 times 10, 70 plus 2, 72. Right? And then this time we will divide 32 again by 10. Then we will get 3. Since my number 3 is greater than 0, then we will loop back again. Remember that? This time my last digit will be 3 modulo 10. The number is 3. So last digit will be 3 modulo 10 is 3, right? And then my reverse will be reverse time 10. We have 72. Remember that? Our previous reverse. 72 times 10. Okay, then 720 plus our last digit is 3. Then we will get 723, my reverse. And this time my number will be 3 modulo 3 divided by 10, integer number, 0. Now my number is not greater than 0, is exactly 0. So then we will go out of this loop, and then we will get our reverse number equal to 720 plus 3, so 700. Also, you may find different algorithm to solve this problem. Okay. Anybody has any? So if we follow this algorithm, any number, you may have any number, like there will be a range data type, be reversible. We need to do some practice. Okay, so yes, sorry, your program is not working. I understand. So please bring your program. I will see. Show me your program next time after the class. You want to show me right now or after the class? Okay. So this program we have applied do while here. Okay. So let us see a few more example that we class. So this is program that I want to discuss with you that has some application of using loop and if else if condition. Okay, this program. Okay, okay. Let us try this simple one. So in this program, we want to display a series of prime numbers up to 25. All prime numbers are odd numbers except number 2, right? 2 is a prime number, that is the only even prime number. But all prime numbers are odd prime numbers. So how do we know that a number is a prime number? Simplest logic. How do we say a number is not a prime number, for instance? Let us do it. Yes. Okay. The two factors are the number itself and 1, right? You are mentioning that. So he said a number is not a prime number if it has more than 2 factors. We know that every number is divisible by at least 2 numbers, right? The number itself and 1. If we get at least 3 divisors, factors of a number, then it is not a prime number. There is a way. Okay. Okay, so let us apply those algorithm, those process over here. So for instance here, so this loop. Okay, by the way, in this program has another application that is called, we call label loop. Okay, label, that means a position in your, that is, you see that I have a position over here. So on line 10, it says loop. And on line number 40, I said break loop 1. That means go out of this loop. It will go at this situation if my number x is greater than 25, then it will break this loop. Okay. Maybe I could also say simple break. Okay. So here, what we are doing. So how do we find that a number has more than two divisors? So we will start from dividing the number from 2, right? Okay, and up to the number itself. So for instance, this is here for integer x equal to 2 up to, we did not give any limit over here, but we put limit over here. Same thing, we could put the limit over here also. Okay, and every time we are increasing x, and if we say, so initially I am putting is prime equal to 1, and for instance this case I use integer variable is prime 0. Okay, I could put this is boolean value. This is also applicable. Okay, so if initially I am putting, for instance, is prime equal to 1, so for instance you say, and this, be careful about this loop, or I have one for within another for. Okay, that is called inner loop. This for is inner loop. Okay, this is inner loop. Actually, it is ended here. Okay, this inner loop. For instance, I am getting another divisor d, and d less than x, that means d will be up to 25. Okay, I'm increasing d. If x, okay, my is divisible by d, that means modulo 0, then I am changing is prime equal to 0. Initially, I put is prime equal, initially was here 1, then I am getting back 0. And then after that, if I'm checking if is prime not equal to 0, that means if it is 1, then I am printing. Okay, it is not in the slide, so it may be complicated, but also I see that this problem can be simplified, can be solved in a simple way. There are some redundant steps over here. If you try at home, you may find a different way to solve it simply. So if I run this program, I will get the output. Series of prime numbers up to 25 is 2, 3, 5, 7, 11, 13, 17, 19, 23. If I make change like from 225 to 2500, okay, just I need to make change here in 2 places, 2500. Okay, and if I run this program, hopefully it will give me series of prime numbers up to 2500. This is a complicated program. Try at home. Once you understand the basic concepts, try this at home. Okay, okay. One thing that I want to discuss, for instance, if I want to convert this program in other languages like C# or C++, what do we need to do? Yes. Frozen. Okay, so if I want to convert this program in other languages, like for instance, C# or C++, in C# it is easy, right? We need to change this only this thing, right? We need to put console dot write line, right? Okay, and also in C++, if I want to convert this in C++, you see that this program I just converted in C++. What do we need to do? Instead of system.out.read line, we need to put this way, right? std colon, that is called colon is called scope operator. And then cout, then we need to put this one. And also this line here, there was this line system.out.print. Here we need to make change like this way, because in C++, so maybe I discussed sometime earlier, in C++, the plus operator does not work to concatenate two strings. So this is why plus operator will not work here in C++. So we need to give out stream operator, okay? And if we run this program, it should work for in C++. Okay, let us see another program. Let's see. Okay, maybe there is a, I got it. Okay, how to find factorial of a number? I'm trying to save my space so that I can show it in one screen. Okay, how do we find factorial of a number? I think everybody knows, right? How to find factorial of a number? The result of multiplication from 1 to that number, right? The factorial of 5 equal to 1 times 2 times 3 times 4 times 5, right? 120. Okay. The simplest way to find a factorial of a number is just multiply starting from 1 up to that number. Okay. But there is another way that is called recursion method, is well known. Maybe you will learn not in this course, later course, but recursion is a good way to find factorial of a number. The recursion method, recursion process is the process that calls itself. Recursion method calls itself. That's easy, but we will discuss how to find a factorial of a number in naive way, very simplest way. Okay, so this is our algorithm. Yeah, okay. So for integer 2 I equal to 2, I can start from 1. But there is no need to multiply a number by 1, because when you multiply a number by 1, it's same, right? So for fact integer I equal to 2, we also say 1 up to I less or equal to n number I want to find factorial of, for instance 5. Then I plus plus I factorial fact fact equal to fact times I. What I need to do, I need to initialize this value fact by 1. For instance, you must, whenever we are finding any multiplication result, we need to initialize that value by 1. If we do not do this, you will not get result. Okay? I will show you. And then we will do fact equal to fact times 1. That actually this one line, this is the line that it does everything. So this for loop. Okay. For instance, Okay, this program, when I run this program, it will ask me to enter a positive number. So, but this program has some redundant code. Okay, for instance, if I intentionally enter a negative number, we know that we cannot find factorial negative number. Right? So this is the code. For instance, if we factorial of negative number, if we enter a negative number, then it will tell us. You see that there is a good practice over here. It's a continue loop one. That means what is my loop one started? You see, this is my loop one starting point. Continue loop, and that means if I enter a number that is less than 0, it will take me back to this position. You see that for, and this is an infinite loop. It will ask me to again enter again and again till I enter a positive number. Even if I enter a positive 0, then it will take me factorial of n equal to 0, 0 equal to what? 1. So I have initialized fact equal to 1. It will show me factorial of 0 equal to 1. Otherwise, if I do not put non-negative number, then it will come here block and it will continue this, and it will, when I put a positive number, then it will show me, it will go to break loop 2. That means what is my loop 2? You see my loop 2 is in inner loop, and then it will go out of this loop. If you practice this program, it has a lot of application. The for loop, an infinite for loop over here. It is label loop. It is if, else if, continue, break. Okay. There are several things you can learn from by practicing this program. Okay. Let us run this program. Yes, so it is asking me for a positive integer. Okay, so if I enter a positive integer, for instance 5, then it will factorial of 5 is 120. It is asking me again enter a positive number. Since I have infinite loop, right? Again, until I terminate the program, it will be continuing. Okay, so here, if I enter a negative number, for instance, negative 5, what will happen? Then it will take me to one position over here. It will ask me to enter a positive number. It will not take this value. Yes, it is giving negative number not allowed. Enter again. Okay, enter a positive. For instance, this time enter again negative, then it will tell me same thing. Okay. And this time if I enter 0, then it will show me the factor of my mistake. Bug in this program, because first time it was given by factorial equal to 122, they are updated. Okay, it should be factorial 0 equal to 1. Okay, there is a bug in this program. If anyone can fix it, then appreciate it. Okay. Okay. If I enter a negative number, it will ask me to, and then if I enter 5, then it will give me a factorial of 5. Let me see that it works. Okay, factorial is this. How many minutes I do have? Someone should come from the office, the first the advising office, to give you a message. Okay, let me see if I can show one more program. Okay, maybe in next lecture we will discuss Fibonacci number, Fibonacci series. What is it? Okay, this is simple. This is called inner loop, and this is called outer loop. When you put a inner loop or inner condition within another condition, for instance, when you put one for loop, another for loop, then inside for loop is called inner for loop here, and outside is called outer for loop. But when you close it, remember that you close inner loop first. For instance, we have a box inside another box. Sometimes, for instance, something from Amazon or online, we receive something, our item box, that box is put within another large box, right? So how the boxes are closed? The inner box is closed first, right? And or taped first, then the outer box is taped first. The same thing, when you have inner loop will be closed or first and then the outer loop. So if we run this program simply, then it will show me like this one, like a kind of triangular output. So if you print this program, if you make some changes, you can do, for instance, you can print the numbers in reverse order 5, 4, 3, 2, 1 that way, or you can put in different angle on different shape. Okay, practice this program to display your output in different format, like a pyramid type, or this is a triangle, reverse another kind of triangle. Okay, and see you on Friday, and on Friday we want to finish and wrap up this chapter. Okay, please do some practice. Thank you so much. Come on.